Now we will try to find out the empirical and the molecular formula of a compound. Okay, so we are given again the percentage composition. So we'll do this first step. Assume 100 gram. Hence our phosphorus will be equal to 43 point, okay, 43.64 grams, and oxygen will be equal to 56.36 grams. Okay, so the next second step is to convert to moles. Okay, so this will be equal to 1 mole of phosphorus is equal to 31 grams. So that is written as the mass number in your periodic table. And for oxygen, that is 1 mole will be equal to 16 grams. Okay, so let's find out the answer. So 43.64 divided by 31 grams, so that is equal to 1.41 moles. Okay, 56.36 grams divided by 16, that is equal to 3.52 moles. Okay, third step is to divide with the lowest number of moles. Okay, so dividing both of them with 1.41 moles, because 1.41 is the lesser value for number of moles among the two, for phosphorus and oxygen. So this will be equal to 1. 3.52 divided by 1.41 is equal to 2.50. Hence our empirical formula would look like this: P1O2.5. Apparently we couldn't have a value or a subscript that is in decimal, so it should be an integer. So it would be convenient and appropriate if we could multiply both of them to an LCM, wherein the value will result to the whole number. So the smallest number that I am thinking to convert both of them to whole numbers will be 2. Hence our empirical formula will be P2O5. Okay, so this is our empirical formula. For every 2 phosphorus, there are 5 oxygen atoms present in this compound. Okay, so we could also find out the molecular formula if we are given the molecular molar mass of this compound. The molar mass is 283.88 grams per mole. Okay, so this would be an easy step. So we should multiply P2O5, multiply the subscript with a certain number, wherein the certain number is the ratio of the empirical mass and the molar mass. Okay, so this will be x is equal to empirical mass over the molar mass. Okay, molar mass given is 283.88 grams per mole. For the empirical mass, the mass of this empirical formula, so P2O5. Okay, so I should delete this one. Okay, P2O5. So find the empirical mass. So that is 2. There are 2 atoms of phosphorus and 5 atoms of oxygen. Phosphorus is 31 grams and oxygen is 16. So 2 times 31 is 62. 5 times 16 is 80. Adding these two, this will be equal to 142 grams per mole. Okay, So this is 283.88 grams per mole. So this will be empirical mass is I'm sorry, this should be molar mass. Okay, so this is molar mass over empirical mass. Okay, so this will be 283.88 grams per mole over 142 grams per mole. Cancel similar units, so this will be 1.999 or approximately 2. Hence, we should multiply P2O5 with 2. So, P2O5 multiplied by 2 will be P4O10. Hence, our molecular mass is P4O10. Okay? Molecular formula is P4O10. The empirical formula is P2O5. Okay? So, empirical formula tells us that the actual ratio of phosphorus to oxygen in the compound is 2 phosphorus is to 5 oxygen. Apparently, the molecular formula tells us the actual number of atoms of each element. So, the actual number is there are 4 phosphorus and 10 oxygen atoms present. Okay? So let's have another example. So do this step by step. So for carbon, the first is to assume 100 gram. So 40 grams. Hydrogen is 6.6 grams and oxygen is 53.4 grams. So multiply them with their molar mass factor to convert them to moles. That is the second step. So 1 mole for carbon, that is 12 grams. For hydrogen is 1 mole is 1 gram. And oxygen is 1 mole over 16 grams. Okay. So the answer will be for carbon, that is 3.33 moles. Okay. For hydrogen, that is 6.6 grams. And for oxygen, that is 6.6 moles. And for oxygen is 3.33 moles also. Okay, so divide all the number of moles with the smallest number of moles we generated. So among the three, the smallest number of moles is 3.33. So this will be 3.33 moles divided by 3.33 for carbon. For oxygen, 6.66 moles divided by 3.33 moles for hydrogen. And for oxygen is 3.33 moles divided by 3.33 moles. So we will generate that this will be 1, this will be 2, and this will be 1. Hence our empirical formula will be C1H2O1 or CH2O, a carbohydrate. Okay, so next is we could arrive to the molecular formula. Okay, so molecular formula could be generated by dividing the molecular mass with the empirical mass. Okay, molecular mass is given as 180. Okay, so let's find out the empirical mass. So the empirical formula is CH2O. So let's get the empirical mass. So CHO. So this will be 1 times 12, 2 times 1, and 1 times 16. So this will be 12, this will be 2, this will be 16. This will be 30 grams per mole. Okay, so this will be the molecular mass is 180 grams per mole divided by the empirical mass, which is 30 grams per mole. So this will be equal to 6. So we should multiply the empirical formula with 6. So this will give us C6H12O6 as the molecular formula. So the empirical formula tells us that the ratio of carbon to hydrogen is to oxygen is 1 is to 2 is to 1. On the other hand, we the molecular formula tells us the actual number of each atoms in the compound. So there are 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen.